All right, no, you don't need graph paper today. We're doing more on function rules. So, well, what have we been doing? Well, when we were graphing, let's say, and let's actually start with that graphing, but our title of our notes is function rules. So let's say that I wanted to graph y equals 2/3 x minus 4. What would we do? Well, from the previous days, we would start with a table. We'd write our x. Hopefully my thing will cooperate. We'll write our x, y. And then we choose x's, whatever we want, some negatives, a 0, some positives. But in this case, I'm going to want to choose x's that are divisible by 3 because of my 2/3. Any questions on why I would do that? So I'm going to choose -6, -3, 0, 3, and 6 just to make my work easy. And then what I would do is I'd come over here and I would do some work. I do 2/3 times -6 minus 4. Now this needs to be a fraction, so I put it over 1. I cross cancel and I get 2 times -2 minus 4, because those would cross cancel, right? And then I get -4 minus 4, which is -8. And then I'll do the same thing for 3, -3, so I have 2/3, -3 minus 4. Put that over 1. Cross cancel. And what do I get when I cross cancel?
-1.
Okay, -1, they cross cancel. And then 2 times -1 is -2, and then -2 minus 4 is -6. So I get -6 here. If I put in 0, I hope you can see that this will be 0, and then 0 minus 4 is -4. And do you see a pattern emerging?
Yes.
So what do you think is next?
-6.
Well, let's try it. 2/3. This is why you might as well check. Don't get it wrong unnecessarily. If I cross cancel, 2 minus 4 is
-2.
all right. So next would be 0. And then we would take those points and graph them, right? So that's what we've been doing before. But what if, and this is the whole idea, this thing right here, this is a function rule. This is a function. That's what that is. And with that, we got our table. But what we're doing today is that actually very rarely, if you were ever actually using math for something, very rarely do you actually start with a function rule. You start with the data. So what we're going to do today is we're going to start with the data and see if we can come up with a function rule that models that data. So here's an example. So we're going to start with a table, and for some reason we've modeled something, and this is what we have. And when we're writing our function rule, we need to think, how do we get from x to y? What math do we possibly do here? So we can add, we can subtract, we can multiply, we can divide, we can square, we can root, etc. on forever. Lots of, well, not forever, there's a limited number of things we might do here, but these would be typical for you. How can I go from x to y? Do you see a pattern?
Yeah.
I mean, it's not enough to say that y is counting down by 1. I need to start at x and get to y. Take a guess.
Add.
Okay, what do we add? A 4? So negative 2 plus 4, does that equal negative 6?
No.
Okay, try something else. So on these, and this is important that you actually recognize this,
Subtract.
Yeah.
you need to guess something. So you got to start, and this is truth. You just guess something and see if you get it. So it's guess and test, really. So negative 2, you said minus 4. Do we get negative 6?
Yeah.
All right, now it's not enough to get the first one. If I do negative 1 minus 4, do I get negative 5?
Yes.
Okay, 0 minus 4, do I get
Yes.
negative? So it works on all of them. So what's our function rule? Well, y equals x minus 4 is what you said. And that is our answer. You really do have to guess an operation and test and see if it works out. Any questions on how we, now you might be asking, well, how did you get 4? Someone took a guess. They saw a possibility on the first one. And so you test that possibility. Now it might be, for you, at this level, it's probably going to be no more than 2 steps. So you might need to multiply and subtract. You might need to divide and add. You might need to combine these somehow. But you won't get much more difficult than that, at least not in algebra. All right, so let's try another table. So we'll get this table down, and you could be given all sorts of different things. I like it when you start with a table that the x's go right in order, because then it's a little bit easier to figure out. But you're not always given that. So again, how can we start at x?
Multiples of 4.
Okay, I'm glad you recognized that. So it seems that as we go from here to here, that we're counting by 4s, right?
Mm-hmm.
And when you see that happening, you might think, well, there's a multiplication going on. So we possibly have multiplication in our mix. So can you see a way to go from x to y?
Times 4.
Times 4. So negative 1 times 4 is that negative 4?
Yes.
Negative 2 times 4, is that negative 8?
Yes.
Negative 3 times 4, is that negative 12?
Yes.
Okay, negative 4 times 4, is that negative 16? So it fits our data. So we'd say y equals 4x. All right. Let me get that down. How can we get to y from x? All right, someone take a guess.
Oh, plus 4.
Huh?
No, it's for that one. It's -2, and then it's -4, and then it's -6, and then it's -8.
Okay, so Sarah's found a pattern of some sort. Unfortunately, I need to do the same thing to x every time.
Isn't multiples of 2? Can you multiply and
Okay. So how might we get from 1 to -3?
-2.
Okay, so -2. Let's test it. That's somewhere to start, right? All right. -1 minus 2. Is that -3?
Yes.
Okay. But what about 0 minus 2?
No, you gotta do -4. You gotta add subtract.
You have to do the same thing to x.
But how do you can't. They're all different multiples of 2.
Not a fun, I don't know.
All right, so we were on to something. Let's take another stab at it. Someone else. Give me an idea. So notice how it just progressively gets further and further away. Like this is subtract 1, this is subtract 1, this is subtract 1, and then presumably if we were to start filling in, what would the 3? If I had 3, I'd have -7, right? And if I had 4, it seems I would have -8. So it seems like I subtract 1 each time. I subtract 1 more than before. So when I get to 4, I've subtracted 1 twice, right? And when I've gotten to 5, I've subtracted 1 3 times. And when I get to, well, from y, right? But I need to start at x. So let's go back to the first one. Here's our first example. And in this one, I took x and I subtracted something from it, right? Okay, so let's compare. What if I had this function rule? What if I had y equals 2 minus x? Let's just make a table for that. So if I had 2 minus 1, I'd get 1. If I had 2 minus 2, I'd have 0. If I had 2 minus 3, I'd have -1. And if I had 2 minus 4, I'd have -2. Well, this looks like subtract 1, subtract 1, subtract 1. That's similar to what we just had, right? Okay, so use that, y equals, maybe we have a number here and we subtract x. So try that. What do you think? Y equals, what number could I start at and subtract x and get what they have there? Huh?
Nothing.
All right, let's look at the -4.
But that would make it -5.
So if I did -4 minus -1, that would be -4 plus 1, which is -3. All right, let's check that. What if I had -4 minus, let's try the next one, 0. What's -4 minus 0?
-4.
All right, what if now we have 1, what's -4 minus 1?
-5.
So, this is our rule. Good job.
I knew that, but I was just letting other people do it.
Oh, okay. This is really guess and test. So don't get too frustrated if you don't see it right away. Try something. You have to start somewhere. So let's see if we can get a few principles down that will help us. So for this case, and the first case, whenever we were basically counting up or down, it seemed to have been like x plus or minus something, right? And then when we were counting by multiples, it seemed to be multiply x by something. All right. Let's do a tricky one.
That was tricky.
What's a function rule for that?
That's multiplied. It's squared.
Mm-hmm. Good job. That was a fairly easy one to catch. It was tricky though, because squaring. So 1 squared, that's 1. 2 squared, that's 4. 3 squared, that's 9. 4 squared, that's 16. And 5 squared, that's 25. So that one wasn't too bad. Use this to help you figure out this one.
Ooh.
Or
X squared minus
yeah.
1.
X squared minus 1. There it is. So sometimes when you're given one of these, if you get close, but just a little bit off, maybe it's something and then you add or subtract something from it at the end.
What about number 1?
Yeah.
So that's going to be 0? Why?
Am I a bonobo?
Yes.
Yes. That should be 0. I'm a bonobo.
We know.
Alright, so let's check the 5. 5 squared is 25, subtract 1, and we get 24.
X squared plus 3.
Hey, Ryan.
Hey.
Help! Sorry. That's all up to you.
Help!
I couldn't help it. Ryan, you're the beast.
Good thing Steve.
Alright, any questions on how to get to x squared plus 3? Alright. Yes.
Square root of x.
So y equals root x. Any questions how she got that? How do I go from x to y?
Divide by 2.
But this one's divided by 4, that one's divided by 5, that one's
and I'll
divided by
divide by the number.
Divide by itself.
Yeah.
4 divided by 4 is 1, 16. It's a square root though. 16, the square root of 16 is 4. Right?
Oh, we got absolute value of x.
Yes.
Well, actually,
Taylor does not appreciate your brain.
I was going to say
Any questions how we get absolute value? About that one.
X, absolute value X. What? No, never mind.
Because over here you
Yeah,
get,
I figured that out.
and it also seems that something else is happening. Like how do I go from -2 to 4?
X times negative 2.
So -2x.
Yeah.
So -2 times -2 is 4. -1 times -2 is 2. 0 times -2 is 0. 1 times -2 is -2, and 2 times -2 is -4. So yeah, that works. Actually, I want to keep this. What was up here? Was it 4?
16, 25, 64.
Square root minus 1. Yeah.
So since I wrote the help, you'll know that, well, square root's in this mix somewhere, somehow. The square root of 3 is not 2. The square root of 15 is not 8. The square root of 24 is not 5.
What's the square root of 20? Maybe it's the square root minus 1?
Yeah.
Or no?
There's what?
Plus 1.
So square root of what?
60.
X.
6.
So what would this need to be in order for me to be able to take the square root and get a 2?
Add 1.
Does that work?
Yeah.
15 plus 1, 16. Oh, that should be a 4. Derp to derp.
Oh.
Add 1 here, get 25, so that's, add 1 here. All right, come up with a function rule for that one, bottom right.
X plus 3.
X plus 3. All right, we've done plenty of examples for your notes. Get your whiteboards ready. I'm going to put 3 questions on the board, and I want you to see if you can figure out what each one is.
Do we have to do all of them at the same time?
Yes. Because I'm just going to go over them. It kind of would be kind of weird to.
Do you want our quizzes